Hey guys, welcome back to this episode in my series where I'm going through and doing all the challenges in my book, The C Sharp Player's Guide. We're going to do this knowledge check. I feel like it's been a very long time since I actually recorded one of these, um, mostly because I've been doing the boss battles for a while, and they aren't knowledge checks. They're programming problems. So it feels like it's been a while since I've done a knowledge check, but the feedback I got the last time I did one was, yeah, it's worth it. You should keep doing them. So let's just kind of talk through these. So you can access anything on the stack at any time. That is false. All that data is around, but it's not necessarily well. And there's pictures in here. Let me jump up here to a picture. Not that. I need one with multiple methods. Basically, like when you're in this method one right here, there's just not really a way to reach up to the next frame on the call stack and just access these variables. So they're not really accessible, which isn't true for the heap. So like the stack, it's like because it's a stack. Like there's the things that are buried underneath it. Like they'll be available again in the future. You'll be able to get back to them eventually, but they aren't just like immediately accessible. That doesn't mean that you can't jump through some hoops and uh, you know come up with some clever ways to get access to it. But like you're not just meant to just have access to all of the stuff on the stack. All right, so that's that first one. Let's see. The stack keeps track of local variables. That one's true, and that's like all of your when you have a method and you have local variables. We were just looking at an example of that. That's where they all live. That's the memory that gets allocated for your local variables and your parameters as well. Um, so if we look at that method one doesn't have parameters. There, this one does. Like all of those, they like the N, the A, and the B. They all just live on the stack. So the actual variable location will be put on the stack. Let's see. Number 3, true or false? The contents of a value type can be placed on the heap. The answer to that one is true. It like by default it wouldn't be. The time that it usually is, and there's examples, and there's little drawings of that here too. Like this is a good example of it. Like ints are value types. Yet these, one, two, three of them, here's another three of them. All these characters down here, they're all value types. And yet here they are living in the heap. So the times that they end up on the heap is if they're a part of some other object that lives on the heap. Like these integer arrays or a string. In those cases, they'll because they live inside of the variable. That data lives inside that variable, and for those they'll live on the heap. So um, they can live on the heap. I'm trying to remember now where we talk about boxing. Apparently not in here, so I won't get into too much detail. But there's a thing called boxing where you can, without having like a specific object for it, you can get a value type to also live just on the heap without having to live inside of something else. It just gets moved over, and anyway, it's a little bit complicated. There, somewhere in the book, I don't remember exactly where it talks about boxing and unboxing, but that would be a second way that you could end up with a value type on the heap. So question number 4, I think a lot of people could maybe, if they didn't know the answer to number 3, but then they saw the answer to number 4, they might pick up a hint there about what number 3 is. But so number 4 says the contents of a value type are always placed on the heap. That's false. I mean, we earlier, like those ints that are local variables, they will live on the stack. 5, the contents of reference types are always placed on the heap. That's true. All reference types will be on the heap. The catch there, just to kind of illustrate it, is like here you've got 2 string variables, and these, like the variable themselves, like there's just enough space there for a reference, and that's what these little dots, the arrows are. as these are a reference to something else. So there's just enough space reserved on the stack for a reference, but the actual object will always be put on the heap. And that really kind of is the big difference between a value type and a reference type. Is just reference types, you're always going to have a reference to it. Value types, that it's there, it just has the data right there in place. All right, sorry for scrolling around a bunch there, but let's see. The contents of reference types are always placed in the heap. Yeah, so that's the one we just did. That one is true. The garbage collector cleans up old unused space on the heap and stack. That might be a slightly trick question. The garbage collector cleans up stuff on the heap. It does not touch the stack. But that's because the garbage collector is a memory management strategy. Like, you know, the rule, does it say that in here? The golden rule of memory management is whatever you do, you've got to, like, once you're done using data, you got to clean it up. And I'm pretty sure I know it's in here somewhere. There it is. So I'm pretty sure it's like called out. Yeah, so using the memory is fine, but you need to clean it up when you're finished. The stack doesn't need the garbage collector because it's just really easy. Like you can see it here. Like when we call a method, we allocate more space for some metadata to know like where to go back to. But then A and B get put on here. But then when we return from that method, you see that between here and here, it just, that the dashed line just moves it over. So it can always tell in an instant, really, whether memory is being used for something or not. Because if it's on this side of the line, it's available. If it's on this side of the line, it's in use. The heap isn't that way because it's just kind of allocating kind of arbitrarily, kind of randomly. So I say that it really isn't that random. It's extremely organized. But you as a programmer don't necessarily get to pick the memory locations. And it's like it just finds an open spot that's big enough to hold what you need. So it's not like it's always going to be back to back to back, or doesn't have the same degree of order that the stack has. All right, let's see. So yeah, that's false because it does the heap but not the stack. Let's see, number 7. If A and B are array variables referencing the same object, modifying A affects B as well. Well, we had a drawing of that. It's this right here. So A and B, two array variables that both reference the same array. And if you say A1 square brackets 0, so index 0 is now +1 instead of -1, then it'll change this object over here. And since A1 and A2 both have a reference to the same object, if you now go back and look it up in A2, what's at index 0, you'll see that it got modified to be +1. So you can, because they both reference the same object, they both, when you want to reference, do something with, in this case, A1 and A2, they both, when you ask them to do something, they jump over to this extra object on the heap and make the changes over there, which is indirect. So that's why you'd see the change in both places. So if A and B, the picture we had above were called A1 and A2. In this case, though, if A and B are array variables referencing the same object, modifying A affects B as well. The answer to that is true. Let's see. So the last one here, if A and B are ints with the same value, changing A will also affect B. That one's false, and that's basically because of what we're seeing here. Even if, is there a version of, yeah, there's a version of this where they're the same. So that's what if this stuff isn't making sense to you, it might be good to reread this section. But yeah, so here, like if we copy the value from I1 to I2 between here and here, and so now they have the same value. But this picture is trying to show you that these, this memory location and this one are two different spots, which is different from this A1 and this A2. So in this case, when you do eventually change I1 to 4, it'll update this memory location, but it leaves this one untouched. And the fact that when you do that here, between I1 and I2, it like I1 and I2 are just totally independent versus A1 and A2 that both reference the same thing. They're not totally independent. They're both aware of this other object out here, this array, and manipulating that guy. So they're kind of like sharing the same thing. Um, that's one of the big lessons that I hope you take away from this chapter. But the one thing I will say is, yeah, we're done with that knowledge check now. But just kind of to recap, the big thing I want to say here is I have worked with many C# programmers who don't know the difference between value types and reference types, and they're good programmers. The problem is if you don't understand these differences, that kind of difference, like value type versus reference type, then there's just these little bugs that it's like, well, I was expecting it to work this way and it didn't, because in your mind you're expecting it to work like a value type, but it didn't, or you're expecting it to work like a reference type, but it didn't. So it's an important concept, and it's also the other thing I want to say, and I say this in the book, but if I got your attention here in this video, so I'm saying it again here. This is a thing that makes C# different, like pretty notably different from the languages that are most similar to it. Like a lot of Java programmers and C++ programmers see all this stuff that we've learned all the way through part 1 and all the way into part 2 and think, I know how to, like, this is easy. Like, I've done it in Java, I've done it in C++, but this value type, reference type thing is not how any of those languages handle it. And so even very experienced programmers come in, they think they know what they're doing. They scream through all of part 1 and they get through part 2 quickly as well. But they don't pick up on this value type and reference type thing and how C# handles memory. And then it bites them later. So it's not the kind of thing that I think is necessarily even going to sink in with just reading this chapter once. I think you kind of need to read it more than once. And I say that in the book. I do think it makes sense to read it more than once. But, and maybe back to back, but also maybe like let me jump up here to the table of contents really quick. So like this is right here, this memory management. This memory management stuff, the value type and reference type thing comes up again really big here when we start talking about classes and structs. Where's structs? There it is. Like structs and classes are similar, but one of them is a reference type, classes, and one of them is a value type. The structs are value types. So like it comes back up again there. Oh, hey, there's the boxing and unboxing thing from earlier. So it comes up again there, and it's so maybe the time to read this chapter again is after chapter 28, or maybe wait until the end of part 2 here. Maybe right in here you reread that. But anyway, like I said, I do think it's, and if it isn't making sense, like come to Discord, ask a question here on YouTube, or come to Discord and ask all the questions you've got until it makes sense. It's very useful for it to make sense. You'll have far fewer bugs and confusion if you can like eventually get it to make sense. But it may not just happen just from reading it. You may need to, like I said, keep going through the book and come back to this and read it again, and after you've made a little more progress. Because it's a tricky, but it's also a very important concept. So anyway, that's probably enough for this video. I could keep talking about it for a while, but I'm going to stop myself. So anyway, I just want to take a glance here at where we're at. So let's see. We just did this knowledge check. I do already have videos up for the Hunting the Manticore challenge. So and in the series that I've got on YouTube, I'm trying to keep them all in order. So you should be able to just go from one to the next if you want. But I guess the next one I'll record is, because I've already done the Hunting the Manticore. I'll probably And I know I've done some of these down here too. I think the Vin Fletcher's arrows. So, but I got a few more to do here. Anyway, I feel like I'm jumping around, but hopefully on YouTube, though, it makes sense. So, all right. Thanks for joining me, and I'll see you guys next time.